we want to do an example of plotting tangent and normal vectors along with a position vector to kind of give a little bit of understanding and a little bit of flavor about what's going on for a particular curve. So we have this curve defined by r of t equals ti minus t cubed j. And if you think about that, as you go t in the x direction, you go negative t cubed in that y direction. So what we're really doing is we're plotting a graph that's going to look similar to f of x equals negative x cubed. So kind of keep that in mind to give you some intuition about what to expect in this graph. Okay, so if you're plotting r of t from 0 to t to 2, at t equals 0, we're at the origin. At t equals 1, we're at 1i minus 1j. So we're here. And when t is equal to 2, we're at 2i, but we're at negative 8j. So again, you know, you recall the way that that's not a perfect negative x cubed graph, but it kind of does the trick. So what we want to do is we want to get t of 1 and we want to get n of 1. Now, for the purposes of what we're doing here, we've already covered how to get a principal unit normal vector and how to get a unit tangent vector. So I'm not going to go through the algebra there. Specifically for this problem, the algebra gets kind of nasty. So in the interest of time, I'm going to write some things up, and then we're going to worry more about the plotting than we are the computing. So our tangent vector is 1 over the square root of 1 plus 9t to the 4th I minus 3t squared 1 plus 9t to the 4th square root j. So that's t, and that's not too bad. T prime of t is negative 18t cubed over 1 plus 9t to the 4th to the 3 halves I minus or plus negative 6t over 1 plus 9t to the 4th to 3 halves j. So again, that's a much simplified version, and if we wanted to get its magnitude, we could, we could clearly continue on doing that as well. But sort of in the interest of time, let's not worry too much about that. So then for n of 1, we just need t prime of 1, which is negative 18 over 10 to the 3 halves I plus negative 6 over 10 to the 3 halves j. And then we would get its magnitude. And ultimately, we'd end up with n at 1 is negative 3 over square root of 10i minus 1 over square root of 10j. And t of 1 comes directly from here, which is not too bad at all, which is 1 over square root of 10i minus 3 over square root of 10j. So why am I doing that? Well, I could plot. So really my direction numbers are, if you think of it kind of like rise over run, then for n, your slope is -1 over -3. So you kind of have a slope of 1/3. And on this one, it's -3 over +1. And so you're going to have a slope of -3. Now, again, it's not going to work like that because they're unit vectors. But we'll figure it out. So, plotting n, it goes up 1 and over 3. So you go up 1 over 3. So you're really pointing in that direction. But you only have a unit vector, so you only have something that long. And then for the tangent vector, you have something that goes down 3 and over 1. So you have a vector that goes, sorry, that was supposed to go over 3. Notice I only went over 2. So I really need to redo that. And the reason you want to do this right is because if they're not orthogonal, well, then something feels like it's wrong. So again, you take something of unit length. I don't know if you noticed that. That's kind of a trick for unit vectors. You know that this is length 1, so you kind of have an idea here, and you can use that as kind of a benchmark for how to graph. So this is the graph of the position function, the black dotted line is, and we have the principal unit normal and the unit tangent vector.